Good afternoon, everyone, and welcome to part 6 of ASHRAE Ireland's COVID-19 mini-series. My name is Daniel Coakley, and I'll be chairing today's seminar. Just briefly, the agenda for today's webinar. I'll just give a couple of minutes introduction to the running order for today before handing over to today's panelist, Alan Sweeney of Camfil, on the remobilisation of workforce environments and air quality recommendations. We're hoping to have around 10 minutes of questions and answers towards the end of the webinar, so you can submit your questions throughout the session, and we'll try to get to them towards the end of the session. So if this is your first time joining this one of these webinars, I just wanted to highlight a couple of points regarding participation in today's webinar. So by default, everyone's microphone is muted, but if you would like to ask a question, please use the questions tab or the chat function to submit a query, and we'll do our best to answer it during the session. You can submit your questions at any time, so I'd advise you submitting them as early as possible so we have a chance to get around to them. And if there's any issues with the questions function, or if you want to ask any follow-up questions afterwards, you can email myself at secretary@ashraeireland.org, or Alan has also provided contact details for himself, which will be shown later. With regards to handouts, there's a copy of today's presentation material available in the handouts tab if you're logged in online, and the handouts will also be made available on our website later on this week. And lastly, when the seminar is finished, you'll receive a very short survey, just 3 questions, just to gather your feedback. So we'd really appreciate it if you could answer those. So this, as I said, is part 6 of our COVID mini-series, and it forms part of our ASHRAE Ireland response to COVID-19, which is mainly focused on disseminating guidance from a range of experts for our members in Ireland. There's a section on our website which includes links to relevant information or previous technical webinars, and also a range of technical articles related to those webinars. So this is, as I said, part of an 8-part mini-series, and we've been really lucky with our speaker lineup to date. Lots of really interesting webinars. So if you've missed any of them, I'd advise you to have a look at the website, and you can review any of the previous slides or video recordings. So there's 2 more webinars after this remaining in the series. We've got Jarek Kronitsky, Chair of REVA Technical and Research Committee, coming up on the 10th of September, in 2 weeks' time, and Brendan Reddington of HSE to be confirmed on 24th of September. Just in regards to ASHRAE resources, you can have a look at this slide in your own time. There's a lot of links to relevant information, and I've covered this in more detail in some of our earlier webinars, so if you want to hear more about them, you can have a look back at session 1 in the series. There's also this resources infographic which ASHRAE have prepared, which I find really useful. So if you click the link on this slide, so I'll upload the PDF version of these later during the session, and it'll be available on the website later as well. But this will guide you directly to relevant sections of the ASHRAE website with literature on a variety of different topics. So it's a really useful infographic which will link you to relevant information. There's also the Learning Institute presentations. Again, I'll let you have a look at these in your own time, and you can click on the link to take you to the website to find out more about these presentations. So now I'm going to hand over to today's speaker, Mr. Alan Sweeney. Alan has over 30 years experience in the field of air filtration and currently leads Camfil Group's European Clean Process Division. So, Alan, I'm just going to make you a presenter. And
hi, everybody.
It's perfect, Alan. We can hear you.
You can see
and
me briefly.
See
Can you see
Thanks
my
very
screen
much.
first of all? Daniel, can you see the screen?
Not yet.
No.
Not yet. It may
Okay.
just take a few seconds to load.
That's me. I'll hide my webcam. Looking at me is not a very pleasant experience, I understand.
That's perfect. We can see your screen now, Alan. Thanks very much. I'll
Okay.
mute myself here.
Okay, everybody. First, thanks for the invite today, and a little bit about myself. We're going to talk about remobilization of your workplace environments and how air filtration can help, and then look at the air quality recommendations according to some standards. And it's good to see that REPRODUTION speak in a couple of weeks, because a lot of the standards that we discuss and recommendations we discuss come from REPRODUTION. As Daniel mentioned, my name is Alan Sweeney. I'm the segment manager for clean process for Camfil in Europe. I have 30 years experience in air filtration, and I'm a key contact for anybody who works in the global pharmaceutical, life science or hospital, typically industries in Europe with Camfil. I'm a member of the ISPE, based in Dublin, married with 4 children, and my hobbies vary. Contact details are there, and we'll also have some contact details for questions with a webinar's website or webinar's email address I'll show you in a second. Very briefly, Camfil are a global organization based in Sweden. We have 55 years experience in clean air, nearly 5,000 employees. We're 815 million euros in sales. We've got 30 manufacturing sites and then a further 30 countries with sales offices. So we're a large manufacturer of air filters and clean air solutions. A lot of Irish involvement, ex-Irish CEO, myself, and some other Irish president of Europe, etc., etc. So Swedish HQ, Swedish family company, a lot of Irish involvement. As is mentioned earlier on, if we can't answer questions today, you can email them to camfil.webinars@camfil.com. And if anybody, because of the recommendations and we're going to discuss HEPAs today, if there are requirements or any information needed on looking at if you're a user of filters or AHUs, ventilation systems, if you need any advice or local help in Ireland, and the MD of Camfil Ireland, Paul Flanagan, whose email address is there, has agreed that anybody who contacts him, they will look after with a survey if upgrades are needed based on what you see today. Our agenda. We've had a number of these webinars throughout Europe, and some of the info on the virosphere and some of the methods of contamination come from an expert, Gonzalo Pascual, who's based in Madrid in Spain and works for both WHO and a lot of universities in the area. The agenda is on the screen. I won't go through it all, so let's just begin. The interest in air filtration at the moment and upgrades in air handling systems are based on the current viral problem that we're having, or COVID-19. There are very many ways of looking at the number of viruses that are out there. It's reckoned there are about nearly 5,000 viral species. If you look at it regarding mammals or primates, there's 184 different viruses in one single primate species. If you look at the number of different types of mammals, that gives you 1 million different types of viruses. If you look at the number of single cell organisms as we know them, there are 1.7 million eukaryotic species or single cell organisms. If we take again 184 different viruses and look at that, you're looking at 320 million types of viruses. So either way, there are lots of viruses out there, and we've been dealing with them for many years. Our current friend is COVID-19, and we look at the transmission rate by the basic reproduction number, and as has been on the news frequently, we're trying to keep it as low as possible. You can see the basic reproduction numbers for various viruses there, and COVID-19 is 2.5, or for every 1 person infected, it's going to infect a further 2.5 people if it's not controlled. Measles, as you can see here, is very, very infectious, right through to rubella and COVID. And most of the ones that are seriously infected, we're already inoculate or vaccinate for. There are various ways that these viruses can be transmitted. Contact, air, eating, you can be inoculated against them or with them, and then there are other methods of transmission. But unfortunately, the current virus and all viruses can be transmitted through airborne means. When we cough or sneeze, you produce aerosols, and these larger aerosols will fall out and settle on surfaces, hence our need for constant hand washing, etc. But unfortunately, a lot of smaller viruses will hang around in the air, and we'll discuss what's been found out recently in later slides. There are a lot of preventive and protective measures. You've all been made aware of them every day since this crisis began. Wash your hands often, sanitize constantly, avoid close contact or social distance. Wear a face mask. Stay at home or self-isolate, and always cover sneeze and coughs. And we're all aware of this now with the advice that's been given and the predominance of signs and people wearing masks, etc. And again, there are various masks, N95 or FFP filtering face pieces, etc., of various grades from FFP1 to 3, and even using an FFP3, which is the highest level of face protection, which they're using in hospitals, etc. It's still recommended that you cover eyes, use eye protection. We still increase hand washing. We still look at cough etiquette. And even with all those safety measures, the guidance is that we are only 80% protected against this current virus. So we've got to be careful. And many of us spend most of our time at present indoors. And unfortunately, whether it's during this crisis or in general, once we're indoors, the indoor environment can be up to 50 times more polluted. Everybody here in the ASHRAE Association is dealing with ventilation, dealing with filtration, and dealing with indoor environments. So airborne particles come into our buildings typically through open windows, etc., but also through ventilation systems. And what we're doing is actually concentrating pollutants from the outside air. So you need to be careful with the ventilation systems and ensure the correct level of filtration is used to catch and trap those various pollutants. But at the moment, we've got the issue that we're also generating indoor contaminants or generating the contaminants inside the buildings. Typically, they would be generated inside the buildings with furniture, decor, kitchen odors, maybe machines and printers inside in offices, etc. Now, various products emit various volatile organic compounds, such as paints and markers and various photographic solutions. So there's lots of indoor contaminants being generated in our indoor environments. Unfortunately, at present, we now have the added risk of people coughing, sneezing, and generating aerosols, which can be transmitted, as we said earlier on, either by breathing or by touch if they fall out of the atmosphere. And during all this, when we're indoor, it's a HVAC system, as you all know, that handles the heating, ventilation, and air conditioning in all of our buildings. I'm sure most of you understand how a HVAC system works, but if not, very briefly, air enters through an outside air duct, typically passes through stage 1 of an air filter system, goes on to maybe heat exchangers, dehumidifiers, various treatment technologies, goes through a final set of filters to clean it, and then it's disseminated or distributed into the building through ducts and grills down in various offices, etc. Then we remove some air from the building. We continue to bring in fresh air, and we remove some air from the building. Recirculate the air through some filters, again remove some heat and through a heat transfer system, and exhaust the air to atmosphere. So the ventilation system is working very hard to provide the adequate level of fresh air at an economic cost by recirculating or reusing some of the heat and filtering the heat and filtering the exhaust air as best it can. But 90% of airborne contamination cases that we are finding is due to poor ventilation in buildings and offices. If we look at the first one that was really noticed was an issue in China. One guy or girl with COVID, they ate at a certain table, and then within a number of days, the dates are here, other cases were picked up as through transmission. It was worked out that it was actually this distribution of the air in the building that was contaminating people by removing the air from one side of the room and bringing it back across and thus infecting other people in the room. Not a perfect situation. So when it comes to indoor air quality, there are a lot of guidelines and recommendations. There are guidelines for both filter efficiencies and then recommendations for indoor air quality. So let's look at the two main standards first of all that we're going to look at. Two main standards that are relevant and important to understand when talking about supply air into your building or any building is currently the ISO 16890, which is the filter classification, and this replaces the old EN 779 standard. And for this webinar, we're not going to go into the full details of the standard. There's just a table here to look at. People that are familiar with filters would have been previously using M5, M6, F7, F8, F9 as the type or classification of a filter. And that's now changed with the new ISO 16890, which is a global standard, fully introduced globally and fully introduced since the beginning of last year in Europe for both design and existing buildings. Here we're classifying the efficiency of a filter according to an actual particle size. So it's particles between 0.3 and 1 micron, up to 2.5 microns or 10 microns. PM10 filters are typically coarse, PM2.5 are medium, and PM1 are fine filters. So as you go from a PM10 to a PM1, you're going up the classification or the old class of filters. Again, if anybody wants more information on this, I've done webinars for ASHRAE and some other societies and various universities around the country on this. We have a full slide set available. If you're interested, reach out to myself or Daniel. So that's on the standards of air filters. And then when we look at the second standard that was developed in order to support facility management or building management activities, that's Eurovent Guidance 423. This standard helps you select air filters based on two main criteria: the supply air inside and the ODA or outdoor air and the area that you're in. And you can see that they're for general ventilation or industrial ventilation. Supply 2, for instance, in general ventilation, so SUP2, sorry, will be kindergartens, offices, or any area that's going to be permanently occupied with people. And the same inside in an industrial ventilation or a plant with industrial ventilation. SUP2 would be again applications with medium hygienic demands. So there's a difference between the general and the industrial ventilation classes. But the guidance given for filtration efficiencies comes from looking at the ODA or the outdoor air quality, so the area that you're based in, and then the type of filter you would use to create an SUP1 or an SUP2, etc., type of indoor location. So ODA is the other guidance that's given. And ODA is easy enough to define. It's based on the place where your office or building or industrial premises are located. ODA 1, for instance, would be an area where the WHO classifies it as being fairly pure air. So 10 micrograms per meter cubed for a PM2.5 size particle or 2.5 micron particle, and 20 micrograms per meter cubed of air for PM10 or 10 micron size particles. That's what they consider to be fairly pure air. ODA 3, and that would be a fairly clean environment. Maybe you're out in the countryside, you're out in a nice clean area. If you go to ODA 3, you're looking at large cities. So it goes from ODA 1 to ODA 3, from very clear outdoor environments to ODA 2, which is medium-sized cities, not too much industries, not too much traffic, to ODA 3, which is very heavily populated, lots of people moving around, lots of industry, lots of traffic. And to look at how to achieve, say, for instance, an SUP or SUP2 environment, you would take the area you're in. So let's take an ODA 3 area, heavily polluted or highly polluted area, and look at the filtration stages that should be used to achieve that class of filter, that class of area, sorry. So what they would recommend according to 423 is that you would have either 2 stages, an EPM 2.5 50% and then an EPM 1 60%, or an EPM 1 80% filter in one stage to achieve a SUP2 class environment in an ODA 3 outdoor type environment. So if you want to look at how to achieve various levels of cleanliness in general buildings, I would recommend using the Eurovent guidance. Since the beginning of this crisis, REVA, the Federation of European Heating and Ventilation and Air Conditioning Associations, have given some advice. And again, great to see that you have a representative from that body in 2 weeks to clarify this some more, perhaps. But currently, they've given some guidance. Started in March, Patrick's Day for us, just coincidence. And at that stage, they recommended that ventilation systems, you should increase the air supply and exhaust ventilation. Temporarily turn off rotary heat exchangers where you're going to have both air and heat being exchanged, and do not use recirculation air at all. They wanted 100% fresh air. And they recommended at that stage that air cleaners can be useful in specific situations, but they hadn't looked at specific air cleaners or hadn't looked in too much detail. And that was the initial guidance that was given at the start of this crisis. And again, they've been looking and they've been upgrading and they've been looking at the virus and looking at the infection rates and looking at how people are infected. And they've now come, like everybody else, to the conclusion that this virus is considered airborne and they need to change these guidelines and recommendations again. So they did change them and they need to change them again. So very briefly, a small video on the risk of virus in the air. So as we said, viruses are released into the air by coughing, sneezing. Importantly, they can remain airborne for between 5 and 16 hours, depending on the size of the virus and the room. They travel through the air, importantly, by attaching to airborne particles. But they will travel on airborne particles through ventilation systems. So this can, unfortunately, spread virus throughout your building. So even people that may not be in the same room as an infected person could become infected as you transport virus through a poorly maintained or bad filtered or no filtered recirculation system. So changes were needed. So changes were needed because the virus was considered airborne. They needed to improve the ventilation advice being given to protect people from transmission. And they understood that poorly ventilated areas, these viruses can stay in the air for between 5 and 16 hours. So they looked at the size of the particles, and for us, we tend to say about 0.16 microns or 80 to 160 nanometers is the size of the coronavirus particle. And then it typically travels on a larger particle, which can become or is airborne. And depending, as you can see in the yellow highlighted section here, on the room it's in, this can be active for up to 3 hours or 2 to 3 days on room surfaces, etc. So we all know about social distancing. We all know about wearing masks to protect from these droplets. So that's an important part of our protection. But REVA look at the ventilation industry and they made recommendations for what to do during this crisis. So again, in March 2020, they initially said no increase in no use recirculation. Air cleaners can be used. And they gave specific advice at that time. And they've changed it in August. In August, they've given a more defined level of filtration recommended within guidelines. We'll look at some of those in a second. They now recommend that you can recirculate, but they recommend how to deal with recirculated air. It was difficult in some instances to just simply turn off recirculation systems. They've identified the requirements for when to use air cleaners. And the reason for some of today's discussion is they've identified the increasing importance of HEPA filters and real HEPA filters in these air cleaners. And again, there's downloads of the documents, the full documents here that we're going to discuss for anybody who wants them. It's in the handouts I'm sure you've been given, or else contact Daniel or myself on the email addresses that have been given. So what does a REVA document, a new one, say about supply air? What it says is that you need to focus on the ventilation rates, and they've given guidance on the ventilation rates and a number of air changes that are required in rooms, etc. They've given specific advice on recirculation and outdoor and exhaust air filtration and the use of indoor air quality monitoring. So particle counts, indoor air quality assessments by validation companies, by the correct professionals, etc., etc. They've also, and it's well worthwhile getting this document and reading it in full because there's some good advice here. Bottom line, they've looked at the type of filters that you can use in your systems. And they also give advice, importantly, bearing in mind that these filters will trap particles on which virus may be present. So what they've said is that air filters in general systems do not need to be changed immediately. So if an air filter is in a system and somebody's infected and we know the filter has captured or potentially captured some virus, They should still be changed based on the guidelines and recommendations from filter manufacturers, from your AHU, air handling unit supplier, or from your service company. They do recommend that EPM1 60% plus should be used in all cases. And in fact, upgrading to EPM1 80% will increase protection. On recirculation, they've said, and most systems unfortunately have low grade, what would have been G4 or M5 or ISO coarse now, EPM10 filters in the recirculation systems, and that was primarily just to protect against dust going back up to the ventilation system, and it wasn't for protection of people, just for protection of the actual HVAC system. So they're recommending that a low-grade filter should not be utilized as final protection, or low-grade filter should not be used on recirc. They're also recommending that during the change of air filters, we look after the people that are actually changing them. So during the change of filters in section 4.9 of the safety procedures, they're saying that filters should be changed with the system turned off. The people changing the filter should wear gloves and further respiratory protection, and then all these filters should be disposed of in a sealed bag. The reason for that is that you've got to bear in mind that you're actually catching the particles and catching possible virus on those particles going through the system. And whilst we know that they will die and won't be viable after a number of days, you still got to treat them as potentially infected. If it was a pharmaceutical facility or a containment facility, you'd be using perhaps bag in, bag out, safe change, if anybody's familiar with that type changes of filters for either potent compounds or potentially hazardous filters. Here we're dealing with general ventilation systems, but we should still, in this current crisis, be aware of what's possibly inside the filter and always have our maintenance personnel protected with correct face coverings, masks as high a class as possible, and gloves, etc., etc. And then on exhaust and return air, as we said originally, in March 17th, they said no use of recirculation. This, they understood, was difficult to completely change or upgrade a system and remove the full recirc. So they're recommending now that you avoid central recirculation, but if your recirculation section is equipped with return air filters, you should upgrade them. So to completely remove particles, return air HEPA filters perhaps will be needed, but with the knowledge, and we're all aware that a HVAC system is designed to operate at a fairly low pressure. The filters that are used typically operate at about maybe 60 to 120 pascals, maybe as high as 250 in some cases. But the pressure drops, or the pressure across filters, tends to be quite low in these systems. So they're saying that to completely remove particles and viruses from the return air HEPA filters will be needed. I agree. But unfortunately, due to the higher pressure drop and sometimes special required frames, they may not be easy to install on existing systems. So again, if you're looking at installing HEPAs into a system, and this is not an advertisement for any company, but Camfil, the company with whom I work, have carried this out in many, many hospitals and other environments over the years. So advice is available from us and from other industry specialists. If you cannot get a HEPA into the system, it's recommended that a minimum improvement would be the replacement of the existing low efficiency return filters with at least an EPM 180%, so the former F8 type filter. And this will give you an approximate capture efficiency of 65 to 90% for PM1, which is particles of 1 micron. Not great at very, very low particle sizes, but the best protection you can get in a HVAC system. But the REVA document is now mentioning HEPAs. So why have they mentioned HEPAs, and what's the benefit? They mention HEPAs and they mention room air cleaners. So they mention room air cleaners and they mention UVGI sterilization of air, etc. They mention both of these technologies specifically. So we're looking at filters and air cleaners today because of the recommendation on HEPAs. So to be effective, they're saying air cleaners need to have HEPA filter efficiency. And they are also aware that unfortunately, most attractively priced room air cleaners are not effective enough. So if you're going to look at buying an air cleaner, please look at the various types that are available, and I'll give you some pros and cons in a minute on some of those types. And please be sure that you're getting real HEPA filters. We'll look at that now in a second. The benefits of air filters and HEPA filters is that they can catch and capture virus parts or particles of the virus size and above. But it's critically important that you choose a HEPA that is correctly tested and classified in both the factory according to the standards that we discussed in a second. They also recommend that you select the right size air cleaner. You got to look at least 2 air changes and up to 5 air changes per hour. So you got to look at the airflow rate through the air cleaner and the size of the room, and then deploy the correct amount of air cleaners into these rooms. So one air cleaner will not work in every room. It's not a one size fits all technology. You need to place them in the space where they can be visible, where they are recirculating air correctly, not put in the corner, out of sight, out of mind. It's got to be in a location where it can actually physically move the air through the HEPA filters and filter the air in the room. The benefits and limitations for UVC systems are that they can neutralize viruses on surfaces, but they might have issues with pressure drop, etc. So using a HEPA against the virus. Why HEPA? Well, we're saying that viruses can remain airborne for between 5 and 16 hours, depending on the room, on the airflow design, etc., etc. The HVAC system, the lack of a HVAC system, there are various reasons. And these standard viruses tend to be in the range of 0.12 to 1 micron. A HEPA filter, by the numbers, according to the EN 1822, which is the standard for testing HEPAs or absolute HEPA filters. HEPAs are tested according to what's called the MPPS, or most penetrating particle size. And that tends to be between 0.1 and 0.2 microns. So it just happens to be similar in size to where most viruses tend to fall, or particularly COVID-19. So the efficiency of a HEPA filter against those viruses, and bear in mind that viruses typically travel on larger particles, so it'll be at least on the virus size or bigger. It'll get more efficient as the particles get bigger. A H13 HEPA filter would be 99.95% efficient at MPPS. That includes that virus size. And a H14, which we'll discuss in a second, 99.995% efficient. And that's a huge improvement on the standard ventilation filters that we discussed earlier on. And let's look at those filter efficiencies versus the virus particle ranges. So we look at virus particle range in micrometers, microns there on the left-hand side, between 0.3 and 0.4 microns, between 0.4 and 0.55. And again, bear in mind, viruses can be smaller, but they tend to travel on larger particles in the air. They're not just floating around on their own. They'll attach to larger particles. So we can take particle sizes of 0.3 to 0.4 microns, right up to 0.7 to 1 microns on the bottom. And you can see the increasing efficiency as we increase in filter efficiency. So if we take our most efficient ventilation type filters, looking at the EPM 180 or EPM 185%, or what would have been F8 and F9 in the old standards, if you're more familiar with that. And here we can see that even on the smaller sizes, you're looking at 79 to 80% efficient. So it's much better. It's an improvement on what's probably in most ventilation systems, but it's not HEPA. If we look at it in a different way and look at the summary of the filter classes according to both EN 1822, which is the HEPA filter testing standard, and ISO 16890, which we discussed very briefly earlier on, you can see that as the viruses or the particle sizes decrease, it's more difficult to capture them with the various type of filter. So if you're looking at an EPM 190% on the bottom, right through to an to a H13 filter, you can see that your H13 or HEPA filter is the most effective at capturing those small particle sizes. And we look at the properties of filtration to work out or give you a quick understanding as to why that is. So if we look at how a HEPA works, all filters capture particles. Often the first idea of a filter is that it's like a small net or it's a small pore, so particles don't fit through that net. And that is true. Sedimentation and straining and inertia and various properties happen that if a particle is too big to get through the actual structure of the filter, like a net, like a fishing net, it'll block particles. But that's only one part of the picture, and it's not so relevant for HEPAs because HEPAs operate at much smaller particles, which would find their way through most of those regular HVAC filters we've discussed. So we look at the various effects that happen in a filter. As we said earlier, you've got sedimentation, straining, and inertia, which are for larger particles. The basic media itself catches or intercepts the media. Intercepts the particles, sorry. The interception effect is when particles are moving and they try to get around these particles, and they're attracted by various forces and they are caught by the media. As the particle gets smaller and smaller, these particles move very similar to chemicals, and they move what's called Brownian motion. And here they move and are trapped with what's called the diffusion effect, that they move erratically. They don't move with the airflow, so the air is not actually moving them through the filter. They're moving erratically with what's called Brownian motion, but they still collide with the many fibers that are in a filter. That's why it's important that you look at a regular HVAC filter versus a HEPA filter, and you'll notice that there are very, very many more fibers of much smaller diameters in the makeup of a HEPA filter. And all of these various effects of the fibers, sedimentation, straining, inertia, interception, diffusion, they all work together and give it what's called a combined or total filtration efficiency. And this total filtration efficiency tends to be, as I say, all of these forces working together, but there tends to be one particle that is the most difficult to catch. And that's what's called in filtration standards or terms the MPPS, or most penetrating particle size. And this is the particle size that is most difficult, irrespective of how all of these filtration effects work together, the particle size that's most difficult to get. And the current test standards then say that we must test our HEPA filters at that particle size. So it's a very tough test. And as we said earlier on, that particle size happens to be very similar in size to the current COVID or SARS-CoV-2 virus size. So when we talk about HEPAs and its MPPS, you're looking at that efficiency at particle sizes similar to the current problem we have in our environment. To look at the various test standards that are out there at the moment. For HEPAs, we deal with EN 1822 and ISO 29463. And this classifies the filters into the, as we discussed, H13, H14, or in ISO 35 or ISO 40, ISO 45, etc. Irrespective of how it classifies, if you're looking at the efficiency, and the efficiency is 99 point, in the case of a H14 filter, 995 at MPPS. So if you're looking at a most penetrating particle size particle of between 0.1 and 2 microns, or a virus of a similar size, that's how efficient a HEPA filter is. And that's why the current recommendation from REVA and other people is to start to try and use HEPAs where possible. But as mentioned in the document, they also say that it's important that you choose a HEPA filter, it mentions that some HEPA filters may not be suitable for the job that they're being asked to do. So it's very important that when you're advising or choosing a filter or recommending a HEPA filter to anybody, including the people with whom you're going to help in buildings, etc., that you look at the filter and ensure that it is tested according to EN 1822 or 29463, and importantly, that there is a test certificate given with the HEPA filter. Every HEPA filter should be tested in the factory. It should have an individual test cert. That test cert should give you a range of particle sizes and its efficiency at those particle sizes. It should have details like the airflow, the efficiency, the test environment, the temperature it was tested at, and the humidity in the environment, etc., etc. It should have a unique serial number, and it should be traceable back to the manufacturer and the plant that it was manufactured in. So it's very important that if you're going to start using air cleaners, that you request that these air cleaners have the correct HEPA filter. And I'm not saying it has to be a Camfil HEPA, but a tested HEPA according to EN 1822 or ISO 29463. And then how do they recommend that you handle risks when it's coming from inside the buildings? Well, we've produced a very small video, which I'll show you before we go into the techniques of this. So for office space reactivation, tip 1 is to use supply air wherever possible. So turn off recirculation if it's possible, as is recommended, and filter outdoor air only. All of those filters should be at minimum of EPM 160%. And if recirculation is required, try and install a HEPA barrier somewhere. So whether that's up in the ductwork, that might mean adjusting some ductwork or adding an air cleaner in the ductwork. It typically might mean adding an air cleaner because the ductwork or the system may not handle the extra pressure. Either way, you still got to ensure that all of the human protection protocols are in place. And then they're saying that for added protection, look at air cleaners, plug and play. Can you fit an air cleaner into the indoor environment? So it's a standalone system. It's going to work in conjunction with your ventilation system, but it's a standalone system. And always ensure that sanitation practices are put in place during and after out of hours activities. So we're recommending air cleaners. But air cleaners with real HEPAs. Forgive me. Next slide, please. So again, REV have recommended that air cleaners can be useful in specific situation. They're also recommending that certain air cleaners may not have the HEPA filters that are required. So always ensure you choose an air cleaner with a correctly specified or correctly tested HEPA filter. And choose that solution according to the relevant technology standards and the relevant air filter test standards. Ensure that all components are certified, whether it's in the filter or in the air cleaner, for use in the environment, whether it's a hospital or a restaurant or a general office environment. Ensure the components are certified for use in the correct environment. Ensure that the number of air changes or the clean air delivery rate is correct. And again, REVA have made recommendations between 2 and 5, so ensure you can actually deploy the correct amount of air cleaners to get between 2 and 5 air changes through the HEPA filter. And it's important to ensure that no foreign substance is created in the HEPA filter. So whether it's a HEPA or a hybrid of a HEPA and a HEPA carbon, it's important to ensure that nothing is created with the technology that you choose. And there are different air cleaner technologies out there. REVA is recommending a couple. There are others. Electrostatic air purifiers. These typically have low pressure drops and they've got a low energy cost, and they're attracting dust and other types of contaminants by electrostatically attracting them to plates. So they have the potential to work in certain environments, but unfortunately they've also got some issues with maybe they can't filter the different kinds of bacteria. They can shed. You suddenly get a particle layer, a loss of a particle layer, which will go into the building. They can create other issues like free radicals and ozones, and there's typically high voltages needed. HEPA or HEPA carbon hybrid air cleaners. Again, as we looked at with HEPAs, they typically filter all sizes of particles. You only need one pass through the HEPA. There's no chance of cluster effects for the smallest particles after filtration, and it keeps the distribution, and it keeps the particles in the filter. And these can be used in hospitals, pharmaceutical environments, as well as warehouses, offices, etc., etc. Just be careful here that you need to be sure that, number one, the sound level is not too high. You don't have an air cleaner that's screaming, trying to pull through 3, 4, 5 air changes. And you also got to be sure that you've got a significantly large filter surface area and a real HEPA filter, absolute HEPA filtration, to ensure you're actually using a tested product, and that product has enough surface area to give you a good lifetime while catching the various contaminants that it's working on. Then got ionizers. And here they can be used to kill molds and other viruses on surfaces like walls and other areas, but they shouldn't really be called air cleaners. They have the tendency also to create ozone, and it means that, you know, after they charge the particles, they may settle, these charged particles basically, but that might cause them to settle on other surfaces that has an opposite charge to the charge that's been created, and that could be humans or clothes or walls, which you've got to clean further. So they're just be careful where they're used. UVGI air cleaning is mentioned, and again, that can kill some viruses and bacteria. There are combinations of technologies such as mechanical filtration and UV light. So again, there are other technologies out there, but some of the issues here, you often need to have low airflows in order for this technology to work. There may be dust buildup on UV lamps, and that can be a high cost. They can extract ozone, and they're not really suitable for very dusty areas. And we've got to look at indoor environments and what's being generated inside our environments. Photocatalytic oxidation cleaners, again, they have pros and cons, and the same with various hybrid dust or air cleaners. So just be aware of what's out there and get the pros and cons for each type of technology, and look at the recommendations from REPRODUTION. Back to air cleaners and HEPA filtration. We're involved in air filtration for many, many years, and we're involved with air cleaners for quite a few years now. And we look at the efficiency of the air cleaner. We look at the indoor air quality that's produced by using an air cleaner. And in certain industries and hospitals in particular, they also look at the number of colony forming units, or a unit that's used to estimate the number of viable bacteria or fungal cells in an air sample. And you do that using agar plates. If anybody's familiar with the technology, you put these agar plates around the room and you see how much virus or bacteria is present by what grows on the plates. And by using an air cleaner with 3 air changes per hour, forgive me, this is in non-English, I'm just noticing this now, I picked the wrong slide. You can see the reduction in CFUs, not UFCs, which is obviously Spanish or Italian, in an environment by simply using an air cleaner. So we're increasing the air cleanliness and reducing the number of CFUs. This was a test that was done in the hospital. So look at using air cleaners. Importantly, I'm not going to mention any brands, but look at the air cleaner and look at the number of HEPA filters. In this one here you're looking at, it's Camfil CDM. There are 2 HEPAs. They are large filters in comparison to the size of the unit, so they've got good surface area. They are tested and certified to HEPA filter standards. But importantly, it's a plug-and-play system. So you put it in your room, turn it on, and it starts to immediately clean the air. Set it to the airflow, dependent on the room size, and to get the correct number of air changes. Very simple to use. So put your air cleaner in the room, reduces the indoor contaminants, protects staff, and keeps them healthy. It can work in conjunction with the existing ventilation system. So you can either build it on the right-hand side, build an air cleaner up into the HVAC system, so it helps in moving the air through the HEPA with its own small fan, or stand alone in the room. Before we finish, I'll just look at some case studies where we've actually looked or used these products. So for workplace reactivation, we looked at an office. This is a layout in France that we did recently. Depending on the type of space, no matter what air cleaner you choose, you've got to look at how you deploy them. So in this building, there were different types of spaces. 4 open space areas with 50 people in each area, 7 rooms with 6 people, 3 rooms with 10, 1 room with 20, and 1 dining area with 15 to 30 people. Various square meter sizes, various cubic meter sizes, depending on the height of the rooms, etc. So again, using the recommendations for 2 to 5 air changes per hour, you look at the room and decide how many air cleaners are needed to change or turn the air in that room that number of times. So in the large open space areas, you're looking at 84 pieces or 21 per open space. So again, you could be looking at a lot of air cleaners, but they've got to be deployed where the contaminants are being generated, and that's where people are. You look at 1 room with 20 people, you can use 2 large air cleaners, 4 small air cleaners. Look at the 7 rooms with 6 people, you've got 7 CDMs or 7 individual air cleaners, 1 per room. So you look at the size of the room, the layout of the room, and then the positioning of the air cleaners as an example. So again, in individual rooms, around the rooms, depending on where people are located, etc., etc. In other public commercial buildings, like gyms, we've fitted the range of the brand GoFit in Spain with air cleaners to get them back in action, let people start training again. And the areas of installation there, where again, in the areas people are training, in their office environments, in the reception environments. So again, standalone, small air cleaners in where people are working out, large air cleaners deployed in larger areas, all dependent on the size of the room, number of occupants, and the amount of air you need to change. So air cleaners can be used in many other industries, basically wherever people are. Medical rooms, hotels, any business or any office. But again, the reason to choose HEPA air cleaners is that you can look and achieve the recommended number of air changes per hour. You can do it for different sized rooms, but more importantly, you can do it really safely for the amount of money it costs for a couple of cups of coffee a day. So you got 15 units out of maybe 1,500 euros a piece. This is 22,000 euros. But over 12 months with 166 employees, maybe 30, and they're in the office 30 days a month, you're looking at 50 cents a day per employee. So there's not a huge cost in deploying air cleaners. Just be sure you choose the correct air cleaner. I thank everybody for attending. As we said already, there are links available on the Camfil website, on Reva, and on other industry websites with more advice. The full remobilization webinar with the expert Gonzalo Pascual is available on the link here. If there are any questions, Daniel, I'm sure, has been taking questions during the presentation. I haven't been reading, forgive me. So we can take some questions now. Alternatively, you can email Daniel, or alternatively, email camfil.webinars@camfil.com. Any surveys, advice, or local help that's needed in your office or medical area, or wherever I didn't see the attendees, so forgive me, whatever your area of expertise is, or your area that you work in is, any advice on surveys or local help in Ireland, please contact Paul Flanagan at camfil.com or myself. So with that, we'll take some questions. Do you want to take back control, Daniel? Thank you very much.
Thanks a million, Alan. I'll leave your presentation up for now, just in case you wanted to refer back to any slides.
Okay.
But yeah, there's a questions.
Okay, let's go through some of the questions here. Thanks for joining chapters to all both today's presentation. Oh, am I looking at?
You can probably see the questions as well here. So I think there was a comment just came in where you're getting your espressos for 50 cents. But
the espresso for 50 cents. Yeah. 1 second. Let me go back on my slides. I can go forward, but I can't go back. The espresso for 50 cents. Good question. This was an application where we installed 15 units, and the units were about 1,500 euro a piece. So you're looking at 22.5 euro for the installation. So that particular office was operating for 30 days a month, 12 months, had 166 employees. And you look at the 166 employees by 30 days, blah, 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 works out at 50 cents per employee per day to clean the air based on that capital cost. That's where the 50 cents came from.
Okay. No, thanks very much, Alan.
Maybe it was a silly analogy, and it was done in Italy.
No, I think it was alluding more to where you're getting an espresso as cheap as 50 cents around Dublin.
Yeah. Italy, forgive me. You should maybe equate it to a pint of beer. I'll do it again and equate it to a pint of beer in Dublin. Maybe more relevant for some of us. I can't read the questions here, Daniel. Forgive me. Where should I be looking for questions?
They're quite small. I'll relay them back to you now. So one of the points I think you mentioned earlier was around the various particle sizes. Comparing influenza, SARS, COVID. One of the questions here was, can airborne viruses only be transmitted on carrier particles or droplets? And presumably this is why filtration can be so effective.
Yeah, typically viruses can travel on their own, but it's just unusual. They typically attach to something. And whilst we say the virus might be X, Y, or Z size, they tend to be on a slightly larger particle size. So what we're saying here is that HEPAs work at the MPPS, which just happens to be, and it's just a coincidence, 0.1 to 0.2 microns. That tends to be the most penetrating particle size of the difficult particle to trap for HEPAs. So we're saying that the virus is about 0.16, which is in that range. So it can be trapped, or typically they're on bigger particles, so it or bigger can be trapped. So typically viruses do not just float around willy-nilly. They can do, but they don't. They're normally attached to droplets or in droplets, or attached to dust when they get into the actual air. So the virus size is one thing, but it typically doesn't travel around in that size on bigger particles. I'm not sure if that's answered correctly, but.
Yeah, no, I think so. Thanks very much, Alan. There's a couple of questions here about the point you mentioned on recirculated air. So normally recirculated air in an AHU goes through the supply air filters. Is it the case that filters on the return air only need to be upgraded on AHUs that recirculate the air on the room side of the supply air filters?
Can you say that again? Sorry, or where can I read it?
So it was.
Where am I looking at questions? I can't see questions. Forgive me.
That's okay. So it was on the. Read it again. So normally the recirculated air in an AHU goes through the supply air filters.
Yep.
Is it the case that filters on the return air only need to be upgraded on AHUs that recirculate air on the room side of the supply air filters? Where does that?
It depends on the grade of the recommendation on the supply air side is also EPM 160 plus. We would recommend EPM 180, as I said in the presentation. So I would step one, 100% upgrade the recirculating air filters, because they're always 8 times out of 10 they're going to be a low grade coarse filter, because whoever asked the question is correct. They are not for filter efficiency. They're for filter efficiency, but just to protect the actual AHU. So to stop large dust from getting back up and contaminating heat exchangers, etc., etc. But it doesn't protect against virus at all. So we would recommend immediately upgrading the recirc filters and then looking at the current supply air filters. If you're lucky, you're going to have F7, F8, which is EPM 160 to 80. So you're lucky enough. But if it is below that, you should be putting in a minimum of EPM 160 to 80 is recommended by REVA, because you want to have a good filter filtering the air going down into the building. So the question is a good question, and the answer is dependent on what filters are in the existing AHU. So you should have at least EPM 160 to 80 on the supply air side. And again, going back to, if you look at through the slide set, there are various ways of achieving that. If you're in an ODA3 area, which most of us are, city environment, etc., you can have 2 stages or single stage EPM 180, and that was in this slide set earlier on. So the recommendation is, if you have to recirc, immediately upgrade to at least EPM 180, if possible HEPA, but it's often not possible. Or if your filters in the actual AHU final supply section are not up to EPM 160 to 80, upgrade those as well. So you got to look at the system in its total configuration.
Okay, thanks very much, Alan. I know we're running out of time here, and there's quite a few questions. I might just pass on to you afterwards, or onto the email address that you mentioned. Sure. There's a further question on your opinion on electrostatic or ESP filters, obviously sold on low pressure drop potential.
Yeah, they are. If you look at the pros and cons, we had it earlier on. Yes, electrostatic air cleaners work. Yes, they work for typically, in my opinion, large particle sizes. You know, electrostatic air cleaner creates positive or negative charges onto which the particles sit. Once the power is there, that charge is maintained and the dust is stuck to the electrostatic plates. If the power changes, current drops, you can have a release or a shedding of a particle there, and that's the problem. They don't trap dust inside a media or inside any substrate. It's collecting on a plate, and you've got the possible issue with shedding. It's definitely unable to filter various kind of bacterias, and there are other issues there like creating free radicals and ozone, etc. So nothing against electrostatic air purifiers. They're around for a long time, but perhaps not the most efficient when it comes to smaller particle sizes.
Okay, thanks very much, Alan. I know we're coming up to closing here, so I'll pass on the questions that we didn't get around to today.
Yeah, forgive me. I don't know where the errors are. I could have read them, so forgive me. But if you can pass them on, and we will answer them all individually or to you, and you can answer them as a group. And again, if you want to have any other questions, use the webinars at Camfil's address or Daniel. And thanks for everybody's time today.
Okay.
Just as a closing, on our website there are some tools. This is not an advertisement for Camfil, but it's to help people. We have a free sizing tools for sizing the number of air cleaners you may need depending on the airflow, etc., etc. And air is more polluted indoor than outdoor, so just please be aware that some of these technologies are needed, particularly at present. So have a look at our website or any other industry preferred website that you deal with. But just at the moment, Camfil have put a lot of resources into sizing air cleaner, sizing tools, and some good advice on the website there, which is not a sales deal. So please use it. It's a good information resource. Thanks, Daniel.
Thanks very much, Alan, and we really appreciate your time and a really excellent presentation today. I'm just going to show my screen again for 1 second. I'm not going to run through all of the closing announcements. So I would, as I said, the handouts for today's presentations are available in the webinar at the moment, and they'll also be uploaded to our website later. I just have a slide up here with the links to our various website and social media accounts, so just make sure you follow us, and thanks again to our sponsors. And as Alan said, for any follow-ups to today's webinar, you can contact myself or the contact details that Alan has provided. So once again, thanks a million, Alan, for all your time today, and I'll close the presentation here. Thanks very much.
Cheers, guys.
Cheers.